This is our group members. We are from A4CS1102E. Today, we will learn about a topic in application of differentiation, which is related rates. What is related rates? In differential calculus, related rates problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time. Steps to solve related rates problems. First, sketch the situation. Second, identify rate of changes. Third, determine the equation and formula. Fourth, differentiate with respect to time of equation. And lastly, solve for the unknown rate by substituting specific value.
So, the question. Wheat is poured into a conical pie at the rate of 20 cm³ per minute, whose radius at the base is always half of the height. How fast will the area of the base be increasing when the pie is 16 cm high? Hint: V cone equal to 1/3 pi r² h. Step 1. Sketch the situation. You need to sketch a cone with height 16 cm and radius at 8 cm. Step 2. Identify rate of changes. Wheat is poured into a conical pie at the rate of 20 cm³ per minute. The volume in respect to time, which dV/dt equal to 20 cm³ per minute. Step 3. Determine the equation and formula. As we know, the formula for the conical pie is V cone equal to 1/3 pi r² h. Therefore, we need to find other formula to substitute into the formula above. As mentioned in the question, that radius at the base always half the height. R equal to 1/2 h, 2r equal to h. Therefore, we can use the formula for later use. Step 4. Differentiate with respect to time of equation. How fast will the area of the base be increasing when the pie is 16 cm high? Based on the question, we need to determine the area of the base increasing with respect to time, which dA/dt. The main formula we use is dA/dt equal to dA/unknown times unknown over dt. How to determine unknown? Earlier, rate of 20 cm³ per minute, the volume is respect to time, which dV/dt equals to 20 cm³ per second. So the unknown are both dV, dA/dt equals to dA/dV times dV/dt. Now, how to find dA/dV?
We need to change A with respect to V to start differentiate, that is dA/dV. But we need to use another formula to solve this. The formula used is dA/dV equals to dA/dr multiplied by dr/dV. The unknowns of dr was taken because we can differentiate the formula of base of the cone area and the formula of the cone itself. First, from the formula of circle at the base of the conical, that is pi r², differentiate the area with respect to the radius, so that we will get dA over dr equals to 2 pi r. Next, from the cone formula, which is 1 over 3 pi r square h, differentiate the volume with respect to the radius, so that we will get dV over dr equals to 2 pi r squared. Now, we can substitute into the equation to find dA over dV. Now, from the formula that has been defined, that is dA over dV equals to dA over dr multiplied by dr over dV, substitute all the values for each specific variables. Then, we will get the answer for dA over dV equals to 1 over 8. Step 5. Solve for the unknown rate by substituting specific value. From the main formula we used, that is dA over dt equals to dA over dV multiplied by dV over dt, substitute the value as solved before. Then, you will get the final answer for dA.
As the conclusion, in this problem, we saw an important idea in dealing with related rates. In order to find the ask for rate, all we need is an equation that relates the rate we are looking for to a rate that we already know. Sometimes there are multiple equations that we can use, and sometimes one will be easier than another. Also, this problem shows us that we will often have an equation that contains more variables that we have information about. That's all from us. Thank you for watching.